Warning! Tube amplifiers have lethal voltages inside them. Please do not attempt to build, test, or repair these without understanding and following all safety protocols. Hey y'all! Well, we're here to do the next segment on our color preamp. And definitely gonna have some interesting things to show you about this. Some few surprises. I learned some things and I'm gonna share with you what I learned. So let's look at the details of the upgrades we've done to this thing since the last video and then get into testing it. Okay, we got the amp all finished up. Our little black mounting rings came in, which I think really look nice with all the other black stuff on this amp. We got these high-end silver RCA jacks. Those turned out really sweet. Also, after talking to the person that I'm building this preamp for, they're going to mainly be using a CD deck as the input that has no adjustment. And so I added a couple of 100K potentiometers to each of these RCA jacks that will allow you to adjust the attenuation of the input signal, and then obviously you'll use the volume control for the output going to the amplifier. It'll also allow you to set the balance in case it's off a little bit. You know, if one channel is louder than the other, you can tweak one or the other of the potentiometers to get that where you want it. And this way you can adjust the color of the preamp by how hot the input signal is versus how far you're opening up the output potentiometer. The last thing is a customer sent me these cool little laser etched wood skunky design labels. And I wasn't sure what I would end up using them on, but I really think that turned out looking sweet on this amplifier. So let me show you what these potentiometers look like on the inside. So all we've done is run a couple of short wires from this RCA jack to this potentiometer. And then from this potentiometer, the shielded wire runs over here to our tube. And the same thing over on this channel. So, pretty simple thing. And you'll note here the volume control is missing. There's a reason for that. And without going into a spoiler, let's watch the rest of this video. Okay, so we got our signal generator and our scope hooked up. And first we're going to do a test at 1K with a sine wave. And I want to go ahead and get this set to 2 volts RMS, which is right at 5.6 volts peak to peak. That should be right at 2 volts RMS. So go ahead and switch this back to 2 volts. Get this one out of the way a little bit. Turn up our output. And take a look at this as I turn up. Not seeing any clipping. So this preamp will handle 2 volts RMS without clipping. So let's see where it does start clipping. There we go. You can see right there, it's just starting to clip. And let's switch this back to 1 volt per division so we can measure this. And we got 1, 2, 3, 4, 5. It's just a little over 2 volts RMS. So honestly, 2 volts RMS output going into this preamp is right on the verge of making it clip. So you probably do want to attenuate the signal just a breath coming into this thing if you're going to drive it 2 volts RMS. And I honestly recommend having some sort of adjustment on the input so you can play with the input versus the output drive. So let's come back down to 2 volts RMS. It should be about right there. Again, we're not seeing any clipping. And let's overlay these on top of each other. I'm going to turn the output volume down just a breath until I can get these to lay on top of each other. And as you can see, you're getting really close to the exact same signal coming out that we've got going in. I mean, those are just all but laying right on top of each other. You may have the top and bottom rounded just a little bit, but honestly, that's not a bad thing. So let's go back. Let's keep this 2 volts RMS going in and leave this kind of maxed out so we can see what some of these other waveforms look like. Let's go ahead and switch this thing to a square wave. Guys, that's a really nice looking square wave. I don't see anything wrong with that. There's no ringing. And just to note, my signal generator doesn't generate the cleanest square wave on the planet. And so this is an old scope too, so that little bit of the line leaning a little bit isn't anything I'm concerned about. Now I am curious, let's see what the low frequency looks like. As you can see, my signal generator is struggling a little bit here, but this is not unusual to see when we go down to a 100 hertz square wave to see this kind of drop off, which we will probably also see when we put this on the audio analyzer suite. So let's go in the opposite direction and turn this up to a higher frequency. And again, my signal generator is rolling off the high frequency a little bit, and we're seeing the same here. But overall, that looks like a nice square wave and not seeing any excessive ringing. So what I'm seeing on the scope looks like a really nice clean signal. So I think the next thing we need to do is pop this thing on the audio analyzer suite and look for distortion and frequency response and see what playing with the different adjustments on that does to the output of this preamp. Okay, so now we got it on the audio analyzer suite, and first I did a pull at 2 volts RMS with the input attenuators trimming off about 15 to 20% of the signal, which again is what sounded the best by ear. And I wanted to see where the frequency response was there. This is with the output volume control wide open. And as you can see, we got a pretty good bit of low frequency roll off. There's almost 4 dBs, which is pretty substantial. That's definitely going to be audible. And even here at 40 hertz, we've got almost 2 dBs of roll off from the peak. And so I think we're going to need to put the larger output coupling caps in and at least see what that does. I would like to move like this line right here over here to at least the 30 hertz place, if not the 20. You know, slide this whole curve over. And I think raising the size of the output coupling cap is going to do that. So the other thing I wanted to show you is, let's do a pull with the output volume pot set at half volume. Several people were saying this is going to hugely change the interaction between the output capacitor and the volume pot impedance and all of that. So let's run this and see what change we see in the frequency response curve. And I am not seeing a huge difference. If we go to this point over here, we've still got, because you have to compare it to like this point here where it's flat. Where if we're looking at the blue, that's 0.7 dBs up. And we go over here, and that's 1.5 down. We've still got close to 3 dBs down at 20 hertz. So the volume control isn't having a huge impact on the low end frequency. The other thing that people that were saying that looked at the circuit was, as you turn the volume control, you're going to get a ton of high frequency roll off. I'm not seeing any at all. So I think people just totally missed the boat on that deal. So the other thing that I want to do real quick while we're looking at this is see if I can get, by adjusting one potentiometer, see if we can get these to be more even from channel to channel. And there we go. We got the two channels balanced, and you can see they're tracking identically as far as the frequency response. So that's showing me we got two tubes and two circuits that are working identical with each other once we get the pots perfectly balanced. So let's go over here and look at the THD versus frequency. Okay, this was again with the attenuation at about 15 to 20% on the input pots with 2 volts RMS coming in. And you can see here it starts out at 2%, down here at 20 hertz, and then it slowly ramps down to where once you get down to about 200 hertz, it stays here at around 0.5% all the way up the frequency range. And you can see the harmonics are what we want to see. The first few are spiking, and then after that it just falls off. Earlier when I was doing it with no attenuation, we had the distortion spikes were all the way across this scale, which is not what we want to see. That's definitely the nasty audible distortion stuff. So you can overdrive this amp and make it sound bad. So if you don't have an adjustable output on a DAC or something like that, I highly recommend that you put some attenuators like I put on the front end of this one. So again, this was with the volume control set wide open. I want to set it on half volume and do this again and see what our distortion reads. Well, honestly, this isn't quite what I was expecting, but it does show that putting the volume control on the output as you reduce the signal coming out of the preamp, that you're not removing the harmonic distortion, which is what we're trying to create with this color preamp. We've got a little bit lower distortion here at the bottom end, and it's actually a little bit higher down through this whole middle range, but it's still under 1%, which sounds great to me. So I'm going to turn this down to about 1/4 volume and do one more pull and see what that does with the distortion. So you can see here, lowering it down to 1/4 volume, we've got the exact same distortion profile that we had with the amp set at a half volume, which most preamps don't do this. The distortion levels will change based on where the volume control's set, but the whole point of the way this one is designed is so that as you vary the output of the preamp, this color or harmonic distortion that's being added through the preamp doesn't change with the volume. So I want to try one last pull and try this at 3/4 volume, because that's probably going to be the range that you'll be using this preamp, is between 1/4 and 3/4 volume. And if we've got the same distortion profile at 3/4 volume, I think we've got a win here. So we can see here as we turn the volume up, it looks like the distortion goes down slightly as more signal is coming out of the preamp. And when I stop to think about it, that's actually kind of ideal, because the amplifier that you're driving this with, the distortion is going to go up as the input signal gets higher. So if the distortion of the preamp gets less as its signal gets higher, it'll compensate for the distortion in the amplifier going up as it gets higher volume. So the last test I want to do here is leave this preamp set at 3/4 volume and then lower the input signal or the attenuation on the front end and see what that does to our distortion signature. And this is exactly what I was hoping to see. So as you can see here, now we've got down to 0.18% distortion and under 0.2% distortion across most of the audible range by turning down the input signal and turning up the potentiometer on the output. So the balance between the adjustment on the input potentiometer versus the output potentiometer, you can adjust how much harmonic distortion this preamp is injecting into the source signal going into your amplifier, which is exactly what we want this thing to be doing. So I'm going to stop the video here, power the amp down. I'm going to solder in the larger 6.8 UF output capacitors, and then we're going to come back and see what that does for our frequency response. Okay, so I flipped the amp over and soldered in the 6.8 UF Mundorf caps. When I was first looking at this preamp and looking over the sizes of the coupling caps and all the other stuff, I pretty much suspected that we were going to have some issues with low frequency roll off with the 1 UF cap on the output. And so when I was ordering the smaller coupling cap, I went ahead and ordered a 6.8 UF because that's what I had calculated. It would probably need, in conjunction with the 10K potentiometer, to avoid this low frequency roll off that we saw. So we've got our frequency response screen up, and let's go ahead and put in our 2 volts RMS. We've got our attenuator set at about 15% on the input RCA jacks, and the output potentiometer wide open, and here we go. Let's see what we get this time. And there we go. There's our low frequency response we were missing before. Those coupling caps definitely fixed that. It doesn't look like we have more than about a half a dB of roll off. Let me tweak the attenuators, see if we can get these together, and there they are. That's going to work awesome. Wow, what just happened to that one channel? That's not good. Let me wiggle the jacks around a little bit and make sure we don't have just a loose connection. And do another pull here. Everything looks good. And let it run. And we've got one channel. Wow, I have no idea what happened. But something happened. Anyway, I guess we're going to need to look into what's going on with this preamp. Something happened to it. Well, that testing session went less than ideal, but we did learn something from this, and I'll explain what happened. When that initially happened and it dropped that one channel, I was totally baffled about what was going on. Now, in hindsight, thinking back, I remember when I was doing some of the higher power level stuff on it, I smelled something. It wasn't really a burning smell, but something getting hot, and didn't think a whole lot about it. Thought maybe I'm burning some skin oil off the tubes or something, and just didn't think too much about it. But again, on hindsight, that should have clued me into what was going on. And as you can see, as I alluded to earlier, the little spoiler of the volume pot's missing. Anyway, doing some further testing on it, it lost the other channel. And I was like, what is going on? And I thought, well, maybe these coupling caps are no good, which would be a shock for Mundorf coupling caps to be bad or die that quickly. But anyway, I soldered the old 1UF ones back in, and same thing, both channels were dead. Then one channel started to come back, and then it went away again. And I was like, man, what's going on? And I swapped the tubes. Then I thought, man, did I somehow cook my analog discovery too? So I hooked up another amp to it to test it out. Works perfect. So it's like, okay, it's not my test gear. So then I thought about this guy. And I got out my own meter, started taking readings across it, and this terminal where the cap hooked up was open to the other ones. And if I pushed on it and wiggled it, it would come in and then it would go away, and then it would come in and go away. And I can smell it, and this thing definitely got cooked. My only thought is, this is one of the lower cost kind of metal double gang ones that are, $3 or something like that. Usually, I have no idea what the power rating of this thing is. And I'm guessing this must be like a 20 milliwatt or something like that, and it just wasn't capable of dealing with the current coming through it with the new coupling caps. And also pushing it as hard as I was pushing it with the analog discovery too. I was probably driving more signal through it than you would ever do, or asking more of this than you would ever actually do in real life, with an amp hooked up to it and stuff. But irregardless, this was the culprit. I guess it lost one channel, then the other one started coming and going, and this was clearly the hot smelling thing that I smelled earlier in my testing. So I've got a higher end Borns half watt potentiometer coming that should alleviate this problem. Shouldn't have any more issues. And we'll put the Mundorf caps back in. As you can see, those 6.8 UF ones brought the 20 hertz frequency response up to within like a half a decibel of the rest of the signal, which that's plenty. We don't need to go any bigger than that. You really want to use as small a capacitor there as you can for a clean signal. And if you're going to use a big cap, you really got to use a high quality one. So if you don't need anything below 40 hertz, you could probably get away with a 2.2 UF or something like that, or maybe even play with a 4.7, but 6.8 will definitely get you all the way down to 20 hertz. So got those parts coming. They should be here in a couple of days. I want to get this thing finished up. This has been dragging on too long. But I will say, learned a lot about this whole input versus output versus the harmonic distortion, and being able to control the harmonic distortion. And that's probably something we're going to focus on in this channel, is trying to use harmonic distortion to our advantage and get this cool sound that you can't get with any other kind of gear. So I'm really excited that kind of tripped up on this, and thanks again for Matt for putting this design together. I think he was really onto something. Got some other products we're going to be playing with, some solid state ones that will potentially be doing the same sort of thing. I'd like to do a few solid state projects, but we'll get into that probably in the Monday monologue. So I hope you're enjoying this content. If you are, please subscribe. Please like the video. Thank to all you Patreon folks as well as donation folks. And until the next episode, have a nice day.